Few concepts in psychology are as widely discussed and as hotly debated as intelligence. It is a term that evokes a range of associations: academic achievement, problem solving ability, creativity, emotional awareness, practical know how, and even wisdom. But what precisely is intelligence? Is it a fixed trait or a malleable capacity? Can it be accurately measured by a single number? And how do newer conceptions like emotional intelligence or multiple intelligences expand or challenge traditional views? The scientific study of intelligence began in the early 20th century when psychologists sought to develop objective methods for assessing cognitive ability. The French psychologist Alfred Binet, commissioned by the government to identify children needing special education, devised one of the first practical intelligence tests. His approach emphasized mental age, a measure of a child's intellectual performance relative to peers. This was later refined by Louis Terman into the Stanford Binet Intelligence Scale, which introduced the intelligence quotient, IQ, a ratio of mental age to chronological age, later standardized using a bell curve distribution. IQ tests quickly gained prominence in educational, military, and occupational settings, offering what appeared to be an efficient and predictive measure of cognitive potential. They typically assess a range of abilities, including logical reasoning, verbal comprehension, working memory, processing speed, and spatial visualization. Factor analytic studies, particularly those led by Charles Spearman, revealed a positive manifold. People who do well in one cognitive domain tend to do well in others. Spearman proposed the existence of a general intelligence factor, G or G factor, as the underlying engine driving performance across tasks. Spearman, 1904. This concept remains central to psychometric models of intelligence. Yet this unitary model has not gone unchallenged. Raymond Cattell proposed a distinction between fluid and crystallized intelligence. Fluid intelligence refers to the capacity to solve novel problems independent of acquired knowledge, while crystallized intelligence involves the use of learned skills and factual information. Cattell, 1963. This distinction helps explain why some individuals excel in abstract reasoning, while others shine in areas rich with cultural or educational content. Both dimensions contribute to overall intellectual functioning and develop differently across the lifespan, with fluid intelligence peaking in early adulthood and crystallized intelligence often increasing well into old age. Critics of traditional IQ testing have long pointed out its limitations. First, such tests are culturally loaded. They reflect the values, knowledge systems, and language patterns of the dominant culture. This has led to systematic biases, particularly in cross-cultural assessments or among individuals from marginalized backgrounds. Second, they focus narrowly on analytic reasoning, largely excluding other dimensions of human intelligence such as creativity, interpersonal sensitivity, or practical problem solving. Third, intelligence tests measure performance under constrained conditions, raising questions about their ecological validity, how well they predict success in real-world environments. In response to these concerns, alternative models of intelligence have emerged. One of the most influential is Howard Gardner's theory of multiple intelligences, which posits that intelligence is not a single capacity, but a set of distinct modalities. Gardner, 1983, identified at least 8 forms: linguistic, logical mathematical, spatial, musical, bodily kinesthetic, interpersonal, intrapersonal, and naturalistic intelligence. This model gained particular traction in educational settings as it resonated with teachers' observations of students who excelled in non-traditional domains. However, it has been criticized for lacking empirical precision and for stretching the definition of intelligence into the realm of talents or personality traits. A more empirically grounded expansion of the intelligence construct came with the emergence of emotional intelligence, EI, a concept popularized by Daniel Goleman, but originally developed in the academic work of Mayer and Salovey. Emotional intelligence refers to the ability to perceive, understand, regulate, and use emotions effectively, in oneself and in others. Mayer, Solovey, and Caruso, 2004. Unlike IQ, which focuses on abstract reasoning and problem solving, EI emphasizes social and emotional competencies, empathy, emotional regulation, interpersonal skill, and self-awareness. Research suggests that high emotional intelligence is correlated with better leadership, lower stress levels, improved mental health, and more satisfying relationships. In occupational contexts, EI has been shown to predict success as strongly as, or even more strongly than, traditional measures of cognitive ability, especially in roles requiring social coordination, negotiation, or emotional labor. Still, emotional intelligence is not a panacea. Debates persist about how best to measure it, whether through self-report questionnaires, performance-based assessments, or behavioral observation. Some critics argue that the concept is too loosely defined and overlaps heavily with personality traits like agreeableness or emotional stability. Others caution against its commercial exploitation in leadership seminars or educational programs that lack scientific grounding. Nonetheless, the enduring appeal of EI points to a broader recognition. Intelligence is not merely about thinking well, but also about living well with others. Recent decades have also seen a shift toward dynamic models of intelligence that emphasize learning potential, neuroplasticity, and context. Robert Sternberg's triarchic theory of intelligence, for example, distinguishes between analytical, creative, and practical intelligence, arguing that true intellectual success depends on the ability to adapt, reshape, and apply knowledge in varied contexts. Sternberg, 1985. This perspective bridges the gap between academic intelligence and the kind of adaptive expertise needed in everyday life. It also aligns with contemporary views in educational psychology, which emphasize the importance of metacognition, thinking about thinking, and self-regulated learning as key components of intelligent behavior. Neuroscience has added yet another layer to our understanding of intelligence. Studies using functional MRI and other imaging technologies reveal that intelligence correlates with the efficiency and integration of brain networks, particularly in the prefrontal cortex and parietal lobes. The parieto-frontal integration theory, PFIT, suggests that intelligent behavior emerges from the coordinated activity of distributed regions involved in reasoning, attention, and memory. Jung and Heyer, 2007. At a cellular level, intelligence appears to be linked with both gray matter volume and white matter connectivity, underscoring that intelligence is a property of complex, dynamic brain systems rather than a localized function. This growing sophistication in how intelligence is understood has important implications for education, talent development, and social equity. If intelligence is multifaceted and partially malleable, then educational systems must move beyond standardized testing to foster a wider range of competencies. Recognizing the diversity of intellectual profiles can help educators better support students with different strengths. At the same time, efforts to enhance intelligence, whether through cognitive training, mindfulness, exercise, or enriched environments, must be grounded in empirical evidence and realistic expectations. Reflecting on these developments invites deeper philosophical questions. What should count as intelligence in a rapidly changing world? Is our traditional emphasis on IQ still relevant in an age where social intelligence, creativity, and adaptability may matter more than ever? Can artificial intelligence, no matter how powerful, ever replicate the moral reasoning, emotional nuance, and contextual understanding that characterize human intelligence? In conclusion, intelligence is not a monolithic trait, but a rich, multidimensional construct that continues to evolve in psychological theory and empirical research. While IQ remains a useful predictor of certain outcomes, it tells only part of the story. Emotional intelligence, multiple intelligences, and dynamic models of adaptability broaden our view of what it means to be intelligent. By embracing this complexity, we can move toward a more holistic understanding of human potential, one that values not only what people can calculate or recall, but also how they relate, create, and grow.